Welcome to the Troika Systems Gravure Cylinder Management System and Return on Investment video. The purpose of this video is to show you the recording and history of gravure cylinder measurements and what that means to the printer, and the reverse return on investment considering time savings in productivity and waste in make ready. So let's first look at the cylinder management system, CMS. So we have here the screen, and if I click onto the site where we would have all of our cylinders managed, then you can see all the cylinders that I have relating to the jobs that are available. I can sort these by different profiles if I need to calculate when to calculate a new measurement, and when I've selected those, whether I then look at volume, depth or profiling. I can of course edit and make my own settings to suit my particular situation. So now I've got all my cylinders here. I'm going to have a look at my jobs, and I have a sample job here, brand A soap. This contains 4 cylinders, cyan, magenta, black, yellow. The last profile date, the last volume measurement, the trend in volume reduction, the current depth, and the trend in the depth. I also have here the distance covered by that roller, so I can enter that information directly from the press. Also, if I have some comments, then I can edit those here. So let's have a look at our yellow cylinder and double click, and this will show me the original cylinder as we received it and the recording of those values, and now the most recent recording. And of course I can look at the history of those recordings. But you can see here that I started off with a depth of 42 microns and a volume of 13.1 cubic centimeters. Now sometime later my depth is recorded as just 38 microns and the volume has been reduced to 11.4. You can see, of course, that we have some information relating to the openings, the cell wall, and the channel information. Again, user configurable. We have green for being acceptable, orange or red for warning or non-acceptance of the values. So now let's have a look at my cylinder for my magenta and my cyan. And you can see here I've recorded readings on the left hand side, the middle and the right of the cylinder, and you can see there's just 1 micron variance, very good, and 0.2 of a cubic centimeter, again very acceptable. The opening, height, wall and channel, again just the same. You can see here though that over time the cylinder has become damaged and worn, and we see that by the reduction in depth and the reduction in volume and the reduction in the opening and cell detail. Therefore I could have an issue with that cylinder. You can see also here the amount of revolutions and distance covered at each measuring date. So this will give us our total distance covered by the cylinder. If I click on the graph option here, now I can see my volume reducing at each measurement point, and therefore if I know my ink or my cylinder volume, I can calculate my ink rheology to match the required density on press, rather than having to pull lots of separate pulls, making lots of adjustments for press and ink to get to where I need to be. Much better we base our judgments on scientific measurement. However, the importance for the gravure printer is knowing how much further the cylinder can travel in printing. And here we can measure the depth of the chrome that remains on the cylinder. So if I look at the depth here, now you can see the value in microns, and as it reduces. The red line here represents the point at which the chrome will be worn through to the copper base, and therefore if I get to that point I will destroy the engraving and can no longer carry out a low cost de and re-chroming. I will have to re-engrave the cylinder. This is a much higher cost, and of course there's a lot of time penalty with that. Now, not all cylinders are the same, so we can adjust our setting to manage that expectation. So now I can see that my 46,000, 50,000, 55,000, I can calculate, I think I can get another 5,000 meters of printing from that cylinder. Therefore, if I run that cylinder on press, I know my run length, I can calculate my ink rheology to match the required density given the volume, and I will know that I will be able to safely achieve that print run with that cylinder. However, it's no good if the run length is 10,000 meters, then I know through that job the cylinder will become worn out and therefore will destroy the job, creating a need to rerun the job and the additional expenses incurred in that. So that is why it is vitally important to monitor the situation. So, having said that, this now gives me full management of all of my cylinders, and the database can cope with an unlimited number of cylinders. So from a few hundreds of cylinders to many tens of thousands, and we can carry out the history of that each time we do our measurement. So now let's see what that means in real terms for the printer using our gravure return on investment calculator. This is available in all currencies, but in this instance we'll be using pound sterling. So if I ask the printer how much the hourly charge out rate for the press time, this is not the cost, this is what they charge to their customer, and typically that may be £400, £500, £600 per hour. So let's leave it at 500. How many working days in the week? 5, 6, 7. Most printers are 6 days a week. And how many weeks is that press available? We have to consider there's planned maintenance, downtime, upgrades to the press, and typically that value is about 48 weeks. The number of presses on site, 2, 3, 4. Let's use just 2. And how many shifts is the press worked on? Most printers were running 2 shifts per day. We know from our experience of over 750 users worldwide that the typical saving in make ready, knowing the volume of my cylinders and therefore the ink rheology, means that we can increase our press time availability by about 1 hour per day per press. So if we work 48 weeks of the year, 6 days of the week, 2 shifts, we will recover 1,152 hours of additional productivity time. Then multiply that by 500, the hourly charge out, then I have the potential of generating an additional £576,000, over £500,000 of additional revenue for that printer. Let's now consider the volume of printing and make-ready waste. So for a gravure printer, traditionally they are long runs, but more and more shorter and shorter runs are occurring, and it's therefore important to calculate this. And I would suggest that we probably aim for 5 jobs per day. In terms of the test printing, the pull on press to generate the correct densities after measurement, that industry would tell us it's between 3 and 5 pulls. So let's use 4. The cost of ink and substrate, and this is a typical packaging printer, but of course could be considerably more for pharmaceutical printers. The average waste generated at each pull, this is the point of media entry into the press to being completed, and that time taken through the press. Typically it's between 150 and 300 meters, and we could probably safely use 250 meters. We already know we're working 6 days of the week, 48 weeks of the year, with 2 presses. Therefore, we would calculate that your annual make-ready waste cost, the material you are putting into a skip, is in the region of £288,000 per year. With our experience of the market, typically a 15% make-ready waste saving can be made. Therefore, I would be putting £43,200 less material in the skip, and therefore that will very easily justify the purchase of the Anycam. In addition, we should consider the de- and rechroming and re-engraving costs if we're managing our cylinders correctly. So how many de- and rechromes per year? Given that jobs come in at least a set of 4 cylinders, typically 6, and we would meant to make those in a reasonable value. So let's use 100. The cost of de- and rechroming, probably around 300, but maybe less. That's a market price, typical of Europe. And if we can reduce that best guessing, best usage of the cylinder, then we should save in the region of £3,000. In terms of re-engraving, which of course is a very much more expensive situation because the cylinder has to be sent away, the time taken for re-engraving, the accuracy of rechecking the engraving for its quality. Again, if we used 100, I think that's probably quite high, so let's use 50. A typical new cylinder in the region of £1,400. Therefore, if we can reduce that by 10%, we will save £7,000. So that is a total saving in cylinder cost per year of £10,000. Let's have a look at our productivity gain, our make-ready waste saving, our saving in cylinder costs, and that gives us an annual value of £629,200. The cost of the Anycam with all of the software and the database management system is typically in the region of £18,500. Therefore, our return on investments would typically be from less than a month to maybe 2 years, depending on which element we use. But if we combine all of those values, we will see that the saving should be well within 6 months. And typically we find a realistic